Welcome to another episode of Dominic Does DIY. As always, like, subscribe, and comment down below if you find this entertaining or useful. Also, if there's something you would like to see or explain, let me know in the comments down below. So let's go ahead and get this started. So today your intern comes in wanting to know some stuff. He was working on a circuit reduction in class, so he thought how hard can it be, and threw a bunch of resistors and connected them with lines to make a circuit. He thought surely it should be easy enough. He showed you a starting drawing, just a mess really, but hey, it looks fine for let me throw some stuff on paper just to work it out in practice. He wants to reduce this circuit to a single voltage source and a single resistor. First thing he does is redraws it so it makes a little more sense and it's easier to read, so you can start seeing some series parallel circuits easier. So he shows you a simplified circuit. You review it real quick and decide, yeah, it is fine. It was a good remake of what he had originally shown you. He then shows you his first step. Seeing an easy series resistor, he turns it into one. So after he combined those two resistors, now he is stuck. He sees no more series parallel resistors in which he can reduce and is asking what he does from here. Surely we'll be able to solve it in some way. So from this point on, what is the single resistor value for the circuit in terms of R? Pause the video here if you would like to work out the problem. Otherwise, continue on and I will show you the solution. This is a bridge configuration. Yes, there are no series or parallel aspects of this circuit we can reduce. So we need to go into a bag of tricks. Looking in the EE bag of tricks, we find some Y delta transformations for the resistors. Also, I'm betting you all were wishing that R9 and R2 in the original circuit were 0.5 R, so that when they were reduced to R2 here, it would be R instead of 2R. So then we could just ignore R3 and short across it to make it simpler. But I didn't do that. The Y delta trick basically allows us to transform either of these configurations into the other. So we can take a delta configuration and turn it into a Y, or we can take a Y configuration and convert it into a delta. After transforming the circuit, we can then reanalyze for series or parallel, and then rinse and repeat as needed as we analyze the circuit. We actually have two delta configurations that we can transform. We have R1, R3, and R7, or we have R3, R8, and R2. We can transform either one of these configurations, but which one do we want to transform? Well, when we take a look at the formula, we can see transforming from delta to Y, if all the resistors are the same, it simplifies for us. So we can see that the formula is RA times RB over RA plus RB plus RC. If we have all the resistors the same, meaning RA equals RB equals RC equals R, then the formula simplifies to just R squared over 3R, which reduces to R over 3. So for simplicity's sake, if all the resistors are the same, it is easier for us to do math, and we can just say that all the resistors are now R over 3, so we will actually simplify that delta configuration. So we will take R1, R3, and R7, and we will convert that to a Y formation, and all of the resistors in that will be just R over 3. So transforming that circuit into a delta and inserting the new arrangement into the circuit, we get the following. Now we have some series parallel circuits we can begin reducing. We can see R1 and R8 are in series, as is R2 and R7. And remember, we are keeping it in terms of R, so R1 becomes R over 3 plus R, and R7 becomes R3 plus 2R. So now we can see that R1 and R7 are in parallel, so we can reduce this further by going ahead and combining those two resistors. So now you can see that the formula is super messy. You can see it right here. It's just because of the way that the parallel circuits are with the 1 over plus formula for parallel circuits. And so we will go ahead and simplify it down. And when you simplify this down, you get 28R over 33. So let's go ahead and do that. So 28R divided by 33. And that is the reduced format for that. So now that we have our system here, now we can go ahead and see that we have R3, R7, and R4 all in series. So let's go ahead and reduce that one down. And then again, for simplification's sake, we're going to go ahead and take that 28R over 33 plus R over 3, and we're going to go ahead and reduce that. And we'll go ahead and reduce that down to 24R over 11. So this will become 24R over 11. All right, we're in the home stretch. So R6 is in parallel with R7, and that'll become 24R over 35. And finally, we have R5, R7, and R10 all in series. And so when we sum those ones up, we get the final answer of 94R over 35. So now let's go ahead and check our work real quick with the simulator. So the original circuit here on the left, if we run this circuit, so the original circuit on the left, this is the one that was brought originally, we can see that it's just under 1.8 milliamps going from the source. And the one on the right, if we check that one, we can see it overlays the yellow line perfectly. So we can see that the current coming out of our voltage source in both of these circuits are identical. So the answer for the intern is the reduced resistor value is 94R divided by 35. Well, that's all I have for you this time. Thanks for watching, and I hope you enjoyed the video. And thanks to all who have subscribed and shared. And I will see you next time.